Should I wait for the little bird, or should I go? I think we're gonna start. Okay, hi, good morning everyone. Thank you for coming. My name is Lexi Brown, and I will be telling you about my research entitled Bats and Batflies Disentangling Coevolutionary Drivers of Host Specificity. But before I dive deep into coevolution, which can get a little hairy, I'm gonna tell you a nice little story. According to Greek legend, the king of a place called Thebes tied an apparently very desirable ox cart to a post in a super impossible knot known as the Gordian Knot. And many tried and failed to untangle this knot until Alexander the Great, of course, with a lot of great cleverness and great strength, eventually freed this amazing ox cart from its Gordian prison. And I tell you this story because we can actually relate this kind of mess of tangledness going on with this analogy to coevolutionary history between hosts and parasites. So we've got a host tree here of host species, and on the right here we've got their parasites. And if we want to answer questions about whether a parasite phylogeny is tracking its host phylogeny, we need to be able to visualize which parasites are feeding on which hosts. And we can do that by connecting the tips of the parasites with the tips of their hosts. And we get something like this called a tangelogram, which, based on its name, you can imagine it ends up looking sort of like this big Gordian mess. And not only do these relationships themselves can actually tell us a lot more than just evolutionary history, they can hint at patterns of host specificity of parasites. And for those of you who don't know, host specificity refers to the extent to which a parasite associates with any number of host species. So a parasite that associates with only a single host species is said to be very host specific, whereas generalist parasites associate with many different hosts. So in a perfect co-speciation specificity scenario, we would expect specific parasites to be parasitizing only a single host with which it actually shares a very congruent phylogenetic topology with, but we know that this is not always the case. We know that ecological context and environmental context is often a lot more important, if not just as important, in dictating host specificity as coevolutionary history is. Which brings me to my study system of the most amazing and gorgeous and complex creatures on Earth, bats. And they're really, really weird, bizarre ectoparasites called batflies, so what are these things? They're hippobacid obligate blood feeders that have specifically evolved to feed on bats and nothing else. They are ectoparasites, meaning they live in and on the external surface of their bat host, and they feed on blood. So like many other ectoparasites, they are capable of moving, and they are mobile. A lot of batflies have functional wings, and they can actually hop from host to host, and in my experience, from host to researcher nostrils, which is great, but you get the idea. They're not sedentary parasites. They can easily move between hosts if they so choose. And batflies have a really interesting reproductive cycle where in the reproductive females will actually leave their host bat to deposit a baby batfly on the roost wall or substrate of bats. So in all life cycles, they're actually in immediate contact with their hosts even when they're not parasitizing them. So you can imagine there are these opportunities for host switching if they so choose, or if they're evolutionarily capable of doing that, which might explain why there's variable host specificity across batflies. A lot of researchers have suggested that there's a tight coevolutionary history between batflies and their hosts, but this has never actually been empirically investigated or quantified until right now. So that brings me to my research questions, which, first of all, how host specialized are batflies of my study site, the Atlantic Forest of Brazil, just in general? And is coevolution the best explanation for this host specificity? And specifically, I would hypothesize that specificity of specialist batflies, those that are found on only a single host, should best be predicted by coevolutionary signal and congruence with their host species, since they should be tracking their host phylogenies due to either reproductive isolation or evolving in isolation with their host as habitat. Whereas on the other hand, the specificity of generalist batflies that have multiple different host bat species should be best predicted by non-coevolutionary predictors, so the ecology, environment, density-dependent factors, because generalists should generally be less constrained in their host choice due to either host choice plasticity or reduced evolution and isolation. So I morphologically ID'd 886 individual bat flies collected by my collaborator here, Tiago Teixeira, from these 14 different fragments in the Atlantic forest of Brazil. I calculated two metrics of host specificity. So first, the D prime specialization index, which actually takes into account the abundance and relative availability of certain hosts, as well as the niche utilization of hosts. So it's an adjusted specificity metric that takes into account rarity and availability of certain hosts, which is a little different from the basic specificity metric, which is just the total number of hosts that a bat fly will parasitize and utilize, which has been used for the most part in other studies of bat fly specificity. And I then amplified for all of these bat flies a short region of the CAD nuclear gene and the cytochromoxidase 1 mitochondrial gene, and created a consensus species tree in Star Beast. And this was used, this tree topology was then used to map onto a trimmed host bat tree, kind of like what I showed you with the fish and the parasites, to calculate a coevolutionary congruent statistic between the bat fly phylogeny and the host phylogeny, using an algorithm, a really cool algorithm called random tapas, which I'll talk about in a little bit. And finally, I wanted to test, okay, you know, I got this coevolutionary statistic. I also have a bunch of different predictors like abundance and phylogenetic distance of hosts. I wanted to see what is actually predicting, using general linear models, these variants in host specificity of the different species of bat flies. So just really quickly to go through this brief overview of this random tapas, which it stands for random tangle-o-gram partitions. We start out with three inputs: our host tree, our parasite tree, and a binary incidence matrix, basically saying 1 if the parasite is associated with that host on the top, 0 if it isn't. And then this is a very fancy global fit method where it basically subsamples one single association from this global tangle-o-gram and iterates it over couple 100,000 times against a null association of a perfect co-speciation scenario, saves a Z statistic, and does that for every host parasite association in the data set. And you eventually end up with this frequency distribution where you have all of your host parasite associations on the bottom, on this x-axis here, and the frequency of number of times that association was subsampled as a one-to-one association across the entirety of your tree space. So it's definitely a really cool program that gives you a quantifiable direct metric of coevolutionary congruence between your hosts and your parasites. And it also gives you this variance to mean ratio statistic, which describes the shape of the distribution and can tell you how equally co-diversification is distributed across the distribution. So VMR of 0 is perfect co-speciation. Every single interaction was one-to-one perfect congruence between the host and the tree. VMR 1 is completely random. These parasites really don't care. And more often than not, you're going to get something like a VMR of greater than 1, where you've got unequal patterns of co-speciation of hosts and parasites across the tree space. So our results, he's very excited about that. I identified a total of 22 different bat fly species from 2 different families. And they vary pretty decently, both in the abundance and their specificity values. So I've got the D prime specialization and the basic specificity. And we got a good range of specificity values. So not all of these are super specific or super generalist. So for example, we've got this perfect specialist, this terrifying Stephen King character looking thing right here called Neotrichobius delicatus, which has both the highest D prime specialization, perfect specialist value of 1, and also only parasitizes 1 host. So this is the perfect specialist that parasitologists really dream of and want to have, especially when we talk about coevolution. And on the other extreme, we've got something like Streblid here, which is definitely stepping out on its primary hosts because it occupies about 5 different hosts and has a pretty low D prime specialization statistic. So clearly there's a diversity of host specificity within bat flies of Brazil. And these patterns become really interesting when we look at the coevolutionary output. So just to orient you, we've got these bars that represent, we've got the bat fly bat host interaction, and just for simplicity, I've excluded the actual labels of them. If you want to learn about that, you can talk to me later. And then we've got the frequency. Remember, there's a direct relationship. So the higher the frequency here, the higher the coevolutionary congruence of that interaction. And the red line is basically this arbitrary cutoff that's saying below which there's no coevolutionary congruence, above which there is. And so we've got a good distribution here. We have this perfect specialist here of Neotrichosis delicatus, which has the highest coevolutionary congruence with its single host called Vampyrex pusilla. It's a fruit-eating bat. And interestingly, it also has the highest host specificity that we saw. In contrast, we've got this generalist parasite that was found on 5 different species, so it gets 5 different interaction bars that fall below, well below that coevolutionary congruence line, and it was also had very, very low specificity. So at least superficially, it appears that there's some kind of relationship between host specificity and coevolution between bat flies, but we do need to concretely confirm that with statistics. But this is what I just showed you, the coevolutionary output mapped onto the final consensus tangle-o-gram, which is super pretty, and I really like this graphic. But on the left tree, we've got our host bat tree, we've got our parasite tree on the right, and all of those connections are color-coded based on where you've got the light blue that represents a low coevolutionary congruence from the analysis, red, which shows a high coevolutionary congruence. So there is a good distribution here. There's a lot of variation going on, and we're starting to disentangle this kind of knot and see what's actually happening and the strength of those coevolutionary relationships within bat flies. And this is just a confirmation that yes, we have a VMR on the left. The variance to mean ratio is clearly greater than 1, so these patterns of co-diversification are unequally distributed. There are some that are really, really matching their host phylogeny and some that aren't. And I'm going to go through this really quickly. So is coevolution actually predicting specificity of bat flies, and what better way than with a beautiful AIC table? So I compared a lot of different models, and basically, when we consider all of the bat fly species together, there's a combination of a bunch of different predictors that are really best explaining host specificity. So not just coevolution by itself, which is kind of the 5th from the bottom there. So there is something that's explaining variation in addition to coevolutionary signal. When we look at just generalists, so those that parasitize more than one host, it's still a little inconclusive. There are a bunch of different things other than coevolutionary signal that are dictating it, including basic specificity, which is just the number of hosts, and I think that might just because D prime and basic specificity are related. And then when we look at specialists, I'm a little reluctant about this just because we couldn't, for a variety of reasons, I only had 3 predictors, but coevolution is a lot stronger in specialists, so I do want to look at that a little bit more. So just to quickly wrap up, there's variability in host specificity of bat flies. They're not by any means super specific or super generalist. They're definitely different, and some bat fly species specialists appear to be tracking their host phylogeny more closely than others. So this is suggesting that specialist flies are evolving under different selection pressures than generalist species, and I would bet you that there's some host ecology stuff going on there, and that it would be really interesting to build the data set to actually look at what ecological and environmental variables are differing between generalist and specialist parasites. And coevolution is not the best explanation, or not the only explanation for host specificity. Again, host ecology, environmental factors, or density dependence, or interspecific competition may be important. And this is important in, bat flies are blood feeders, and they could potentially transmit wildlife pathogens. So knowing which bat flies prefer which bats might actually be important in modeling disease dynamics. And with that, I'd like to thank my lab and have my acknowledgements up here, and thank you guys for coming.
Your specialist fly, was this host only infected by that fly, or did it also interact with other species?
That's a really good question. So that's why the D prime specialization is really cool, because if in that situation, I'll go back, if a host is only parasitized by that one bat fly species, the D prime will be 1. If it's parasitized, I don't know what I'm doing. If it's parasitized by something else, there will be kind of a diminishing in the D prime because it's being utilized by something else. The niche is kind of disrupted. So whereas in a basic specificity scenario, you wouldn't get that kind of information, which is good. So some of them that have a D prime of 1, that means they're only infected by that host. And I think I'm out of time. Thank you guys.